Okay, so this is section 5.1, which covers radicals, rational exponents, exponents in general. A lot of this is review, so expect to recognize a lot of this, but maybe you need a couple of reminders. Okay, so we have the topics I'm going over, rules for exponents, rational exponents, so those are the ones with fractions. Something you might not have really covered before is factoring when you have rational exponents, simplifying radicals, rationalizing the denominator, operations with radicals, and then simplifying radical expressions. A lot of the stuff you saw in bits and pieces on the pretest. So first thing I want to point out are some of the exponent rules we might have forgotten. I think most of you remember what to do if you have two like bases multiplied together. You're going to add the exponents. If it's a power to a power, you multiply the exponents. You can split up a fraction where you can square the numerator and denominator separately. That also means you can go back this direction. Sometimes that's helpful. Don't forget, 0th power is 1. That's always kind of a trick question on quizzes and tests. I mean, it's not a trick question, but people tend to forget what that answer is. This one I definitely saw a lot of people forgetting on the pretest. When you have a negative exponent, you take the whole thing, you move it to the opposite side of a fraction. So if it started off like this, it would become this. And once you move it, the exponent now becomes positive. And then also what to do, and we're going to go a little bit more in depth into this, if you have 1 over an exponent, that can be rewritten as a radical. And if you have a number in the numerator of that exponent, it stays as an exponent underneath the radical. And more on that, some of us struggled with this one, particularly because there was a negative. Don't forget, like the cube root of a negative, you don't have to use I, because cube roots can be negative. So you can evaluate it either way. You can do the cube root first, or you can do the radical first and then raise it to the exponent. Or you can do the exponent first and then take the square root or radical, your choice. So this one, I'm going to show how to solve this with a U substitution. I can kind of explain it other ways if you don't really like this. I'm going to say that, whatever this term is, we are allowed to do this because these two exponents are related by a factor of 2. This one is double this one. So whatever that middle term is, I'm going to call that U. So if I take x to the 1/3 power and I square it, that gives me x to the 2/3. So I can rewrite that as u squared. So we have u is equal to x to the 1/3. So we have u squared minus 6u plus 9. And then that's really easy to factor. Oh, I meant to put a u in there. And then we just substitute in back what we said u was equal to. And I noticed that both of those are the same, so I'm just going to write it once and square it. And that's all you need to do. Don't redistribute that. Don't FOIL it. You're done. Just remember to always simplify radicals, and some of us were forgetting what to do with that number on the outside. So just a reminder, we'll get, we can definitely take out a 9. Square root of 9 is 3. 10, which leaves us with 15 root 10 altogether. Always reduce the radicals first thing, because you never know if things get simpler when you have a simplified radical. We call this rationalizing the denominator because if you can't reduce a radical, it's an irrational number, like this guy right here. So we want to rationalize it by getting rid of it, which means we're going to multiply the whole fraction by the conjugate over itself. So just like when we did the complex numbers, the conjugate comes from changing the sign of the weird part, the radical in this case, and then we distribute And you have to distribute down here too. Make sure you FOIL. So we get 4 plus 2 root 3 minus 2 root 3 minus root 3 squared, which comes out to 4 minus, not 9, minus 3, which gives us a 1. And so then all together we have 8 minus 4 root 3 all over 1. Just like I said before, make sure you simplify everything first before you do the operations with radicals. A couple of reminders, just like with the exponents, you can split up the radical, so you can go forwards and backwards from this depending on what's easier. In this case, it might be easier to think about them separately because you can do the cube roots easier. Remember that square root is the 1/2 power, and so you can take whatever exponents you have underneath and raise them to the 1/2 power instead of thinking about square root. So what you can do is take the exponents underneath a square root and divide them in half, and that's what you get. So for example, we're not going to use half this time. We're going to divide everything. We're going to multiply it by the 1/3 power. So we're going to do 8 to the 1/3 power, x to the 6th to the 1/3 power, y to the 4th to the 1/3 power. And you don't have to write this all out every time, but it might help. And when we multiply those together, well, 1/3 power, cube root of 8 is 2. When we multiply those together, we're going to get 6 over 3, which is x squared. We're going to get y to the 4/3, and we'll deal with that in a second. And then we get z to the -1st. So this guy right here, we're actually going to break that apart and make that y to the 3/3 times y to the 1/3. So y to the 3/3 just becomes y. Y to the 1/3 stays underneath. We'll rewrite that as a radical. And then remember what I said about the negative exponents. So our final answer will look like 2x squared y cube root of y all over z, because we want to move that to the denominator. All right, that's it.